in a moment.
I
I said couple ways. You went back. Don't worry. I know what.
we will first start by reviewing what we learned last time. So last time we learned about density, and density is mass divided by volume. And we also learned that the units are kilograms per meter cubed or grams per centimeter cubed. We also learned that the mass is the amount of matter in an object, and mass is measured by the beam balance and always stays the same. It does not depend on location. And we learned about the conversions as well. 1 kilogram being 1,000 grams, and 1 gram becoming 1,000 milligrams. Learned about the physical changes and chemical changes. So when a substance changes its shape, size, or state, for example, between solid, liquid, or gas, but they still remain the same substance. So, for example, cutting a piece of paper or um, throwing a stone, maybe cutting, um, sawing wood, all of those involve simple changes in shape, sizes, or states. Um, and it's easily reversible. And chemical changes are when a substance transforms into a completely new substance with different properties. And this change cannot be usually reversed. Solvent is the substance that dissolves the solutes, and it's usually the larger amount. Learn this in sort of having a mixture. The larger part of it is the solvent, while the smaller part of it is the solutes. And it can be in any state. For example, in air, we learned that nitrogen is the solvent because it takes up most of the component of air. Lastly, we learned about properties of heated gas. Um, we learned that gas molecules move faster and the gas volume increases and intermolecular forces weaken when gas is heated. Let's quickly solve a simple theory question involving mass changes and some of physical and chemical changes. So this question asks us to explain why the mass of lumpy charcoal remains unchanged when ground into powder, but the mass of the same lump changes when heated to burn. So when this charcoal is ground into powder, every mass remains unchanged because it is only a physical change. Again, when you punch or completely grind the charcoal, it just becomes a powder. It changes maybe in size and shape, but um, the same substance, the grounded charcoal still has the same properties as a regular charcoal. However, when charcoal is heated and burned, a chemical reaction occurs, and this is a sort of chemical change. We see that when burning charcoal releases heat and light energy to form this fire, and it also releases carbon dioxide and water if it has oxygen in the environment. So if we burn the charcoal, the mass of the lump changes because some of the is released as water or carbon dioxide. So that is why the original mass of charcoal might be a little less. Now that was for the reviews, and we are getting into um, a new topic of osmosis and diffusion. So this question asks us to find an example of the process of osmosis. Is it A, selective reabsorption? Is it B, absorption of digested food? C, the spread of petrol scent? Or D, gaseous exchange in living things? Yeah, I think I heard some of you say that is the correct answer. Selective reabsorption actually happens because that's one example that's happening in our human body. And after useful solutes like glucose and sodium, water follows by osmosis. Osmosis happens during this process in the kidney, and it is by selective reabsorption. But what is osmosis exactly? Osmosis is the movement of from concentrated solution, from a less concentrated solution to a more concentrated solution. And this is through a semi-permeable membrane. You can see that on the left, there is only one sugar molecule, and on the right, there are 4 sugar molecules. And all these blue dots are just water molecules. So the right side is more concentrated in the solids because it has more in the same fixed volume. So water tends to move through the semi-permeable membrane to the right. It tries to even out the concentration. To do that, the right side needs more water, it needs more solvents. The water moves from more less concentrated to concentrated, from left to right in this case. And you can see how the sugar molecule does not pass through the semi-permeable membrane. The semi-permeable membrane only allows for water molecules to pass through, no, not anything else. So sugar molecules does not go across. So if you leave it after a while, you will see that the right side will have increased volume because water is moved from left to right. Now let's talk about diffusion, which is the movement of particles from high concentration to low concentration until it evenly spreads out. The difference between diffusion and osmosis is that osmosis is only with water moving between two concentrated and less concentrated solutions through a semi-permeable membrane. Yes.
Your voice is very low. I think we can't hear you. I don't know
Um,
whether your
can you hear me
um
well now?
microphone. Yeah, yes, it's better now. It's better.
Okay. Um,
I think.
oops. Yeah, I'll try to speak a little closer. So if you've heard me right, osmosis is the movement of water molecules only. So this semi-permeable membrane only allows for water molecules to pass through, and it does not allow sugar molecules to go across. Since the right side was originally more concentrated, water molecules tends to move right. So it ends up like this. Diffusion is different from osmosis since it is the movement of particles, usually in a solid, from a high to low concentration. It's basically evenly spreading out. So, and here this person drops a few droplets of this red dye, and these are red dye molecules, and all of these are water molecules. This is highly concentrated. We know from diffusion that they tend to move to form a low concentration. So it does not like to be just stay close to each other. It tends to all move to a sort of low concentration state. So after you leave the solution for a while, you'll see that the dye molecules will spread out evenly in the solution. So this is the end of the process of what we call diffusion. Is this uh, anyone have a question so far with osmosis or diffusion? If you have no questions, let's try solving an example. So here, the question is cockroaches in a cupboard were killed after an insecticide had been sprayed. The insecticide reached the cockroaches by the process of, is it osmosis? Is it absorption? Is it diffusion? Or is it radiation? So the insecticide particle being spread out. If it's being spread out, then it is the process of diffusion. We mainly talked about two, osmosis and diffusion. Osmosis involves this semi-permeable membrane and only allows water to pass through. But this process is diffusion because the insecticide is simply moving from this one high concentrated area to form a low concentrated area. It tends to spread out. And that is how it reached the cockroaches. It's by diffusion. Let's solve a next theory question, which states how potassium manganate crystals are dropped into a beaker of water and formed. This is potassium permanganate. It has this sort of purple color here, And you can see that after you leave it, if after you drop it in water, tends to spread out and form this evenly colored purple solution. So if you state what was observed over here, we can say that the purple color from the crystals will begin to spread from the bottom throughout the water. And B asks us to state the phenomenon demonstrated A over here. Well, potassium permanganate dissolves in water and it tends to spread out. These again, potassium permanganate is a great way this process because it is colored purple and you can see it spread out. And this process we learned was diffusion. Originally, it's highly concentrated when you drop it down. There are high concentrations of potassium permanganate, maybe at the bottom of the beaker. But after maybe you leave it for a while or stir it, it will form this lower concentration. It'll fill up the lower concentration areas and it will be spread out and even. This is the process of diffusion and how it might be demonstrated. Let's look at this another type of question. Just moving on to um, maybe a different topic. So the element used in the manufacturing of electronic components is it sodium, fluorine, silicon, or neon? Um, I've provided some information here that actually silicon is widely used in the manufacturing of electronic components, especially as semiconductors. So the reason why silicon is widely used, C, yeah, and because of its semiconducting properties. Last time we learned about metals being conductive and non-metals being not conductive. There is another group actually, and it is called the metalloids. So here you can see the metals over here, all of them colored in like blue. Non-metals are colored in green, and metalloids, the small parts, their property is being semiconductive. Sometimes they're conductive, sometimes they are not in terms of electricity. Again, this is silicon being used in many parts of electronic components when manufacturing electronic components. It's used to make microchips and also part of the solar panel and also some materials and maybe some parts of glue and as well. From these options, can you find an example of a semi-metal, semiconductor, or metalloid? Is silicon a semi-metal, or is carbon a semi-metal? Is beryllium a semi-metal, or is argon semi-metal? Yes, I think I heard silicon. That is correct. Because you can see here that silicon is colored orange. It stands for metalloids or semi-metals. Carbon is over here. Carbon is non-metal. Beryllium is over here. it's a metal. Argon is over here and it's a non-metal. So the only answer is silicon. Let's look at some more properties of semimetals. And semimetals are metalloids, which are elements that have properties of both metals and nonmetals. For appearance, they often look like just simple metals. They're shiny, but are a little brittle, also like nonmetals. For conductivity, they can conduct electricity, but not as well as metals. And because they are semi, they can conduct electricity, but it does not work as well as metals. For chemical properties, they can behave like metals or nonmetals on the reaction. And examples we have seen here, all of these are semimetals, boron, silicon, beryllium, and all of these, like sort of staircase, you can think of it like that. Um, you can think of it on the periodic table. Metalloids are located between the metals and nonmetals, forming a diagonal stair-step line. Usually it might be colored differently, but that is how you would locate heavy metals. It's maybe good to remember some of them because silicon is important. It is widely used in electronics. Maybe also good to remember boron, arsenic, or germanium. Let's look at this theory question. It just asks us to state three differences between metals and nonmetals in terms of their physical properties. So I have a chart here that compares physical properties of metals and nonmetals. So metals are always solids, maybe, but nonmetals may be solid, liquids, or gases. That is one difference. Maybe another difference might be metals are hard, um, but nonmetals, which are solids, are often brittle. Metals can easily bend and can be flexible and hard to break, but nonmetals are really brittle. They break easily. Depends on the structure, but most nonmetals are breaking easily. And these are some other differences, but you do not need to know all of them. Just remember maybe that metals conduct electricity, non-metals do not. Metals are really hard, non-metals are brittle. And maybe another example you might want to remember is that metals tend to lose electrons. We learned about last time, um, learning about cations. Metals want to lose electrons to get to the ideal gas. And nonmetals tend to gain electrons to form its eight valence electrons. This is another really important difference that we learned about last time. And you do not need to know all of this. Maybe it's good to maybe read over some of the properties. but I will maybe send you this slide and this um chart a little later after class so you guys can look at it once more. But let's move on to the next question. In making ornaments and jewelry, non-reactive metals are preferred because they, is it A, are corrosive? Is it B, are attractive? Is it C, do not retain their luster? Or is it D, do not react with atmospheric oxygen? The answer is B. They do not react with oxygen because non-metals, not reactive metals, which are, for example, gold, silver, or platinum, are often used in jewelry because they do not react with oxygen in the air. This means that they do not rust or do not tarnish easily, and they keep shine, which is luster, which is all kind of mentioned here for a long time. So, corrosive are corrosive. These are actually opposite. These are non-reactive metals are less corrosive. And for C, this is also the opposite. Non-reactive metals do retain their luster, their shine for a very long time because they, again, do not react with oxygen to rust. So on the left, this is maybe iron experiencing rusting. It forms a new substance. Um, this is a process of actually chemical change. So maybe important to know rusting is a chemical change, and this is a completely different substance than just regular iron. But gold does not rust, so it keeps its shiny property. This next question, if the following method can be used to prevent iron from rusting. We have different options here. We have alloying, keeping the iron in a desiccator, keeping iron in a moist environment. So iron reacts with oxygen and water to form rust, which is a different substance. But here, painting forms a protective layer and it prevents exposure to water and oxygen. So painting might be one option. Alloying means mixing iron with other metals and make it more resistant to rust. So alloying might be another option to prevent iron from rusting. Desiccator actually removes moisture, preventing rust formation. Since form a rust, we need oxygen and water. And without water, rust will not form. So desiccator removes moisture and it prevents rust. Number four, however, it says keeping iron in a moist environment. This will actually promote iron rusting because iron reacts with oxygen and water to form rust, and more water means that it has a higher chance of forming rust. So the answer is C, 1, 2, and 3 only. Let's focus on alloys because this is This comes up in theory questions often. So maybe it asks you what is an alloy, and it should be answering that alloy is a mixture of two or more metals, or maybe metal and a non-metal to enhance strength, durability, or resistance to corrosion. This is to stop the process of rusting, is to mix two or more metals. Examples of alloys are steel, which is a combination of iron and carbon, and these are used in strong and used in construction. There's also brass, which is copper and zinc mixed together, usually in used in musical instruments and decorations. Bronze is a combination of copper and tin and used for statues and medals. Stainless steel, which is a combination of iron, chromium, and nickel, which is very resistant. So people often um, say that their steel is stainless steel, and they are saying that this steel is very resistant to rust. So maybe the theory question asks you to name the constituents, the parts of an element in brass. We can see here that brass is a combination of copper and zinc. So we put the answer is copper. And the theory question might also ask you to explain why steel is preferred to iron in building construction. Well, steel is much stronger than iron, and unlike iron, which rusts easily, certain types of steel are more resistant to corrosion. So steels are preferred than iron, usually building because they are stronger and more resistant to corrosion. Maybe waiting for a couple more seconds to copy this down. If you're going to copy some notes, I recommend writing down these. Steel is iron plus carbon. Brass is copper plus bronze is copper plus tin. Stainless steel is iron plus chromium plus nickel. And all of these are called alloy. The big picture here. It's a mixture of two or more. Maybe it's good to copy down what I've underlined. So okay, so I think if you are done with copying all of this, on to the next slide. So this question says urea is a good source of, is it A, phosphorus in the soil, B, calcium in the soil, C, sodium in the soil, or D, nitrogen in the soil? For urea, chemical formula is CONH2, 2, and urea is a nitrogen-containing organic compound, and it is often found in urine. And urea is often widely used in fertilizers, animal feed, chemical industry, and skincare products. These are maybe another name. Um, carbamide in the IUPAC system, in the naming system, might be called different, but we can see answer is D, provide nitrogen, and that is the important thing to know. Urea is a nitrogen containing organic compound and is used in fertilizers. You can see here. Farmer is using urea as a sort of fertilizer to make the plants grow faster. Let's look at this question. The simplest way of making well water suitable for laundry is by, is it A, adding copper sulfate, B, filtering, C, boiling, or D, adding chlorine? I've included the answer here. Um, Boiling is actually the simplest way to make well water laundry. Boiling the well water kills bacteria and germs. It softens hard water slightly by removing water's calcium content, and it removes some dissolved gases that might cause odors. So boiling is a really good way to make hard to make water more clean. And again, part of it is because it kills bacteria and converts hard water to soft water by removing water's calcium content. So hard water, examples of hard water are seawater, well water, groundwater, and borehole water. Hello, can you hear me? So we can continue where we left off. Here we're talking about hard water and soft water. Hard water being seawater, well water, groundwater, borehole water, or river water. All of those are hard water because it contains high concentration of maybe magnesium and calcium. Soft water are things like rainwater, distilled water, boiled water, or melted snow. And we can convert hard water into soft water by boiling. We talked about boiling, and adding washing soda can actually help. Um, and ion exchange methods such as water softeners. There are many different types of water softeners that you can use. And you can also use distillation. So we learned last time about distillation being um, boiling water, boiling the solution at a specific temperature. And it only allows soft water to be evaporated and collected at another flask. So distillation might be another way, but um, the main way that maybe you guys need to know is by boiling. And now we are almost done with this chemistry slides, but in the last couple slides, let's quickly learn about some protective materials. So this question asks us to state the hazard that could be prevented when each of the following protective materials are used in the laboratory. So for gas masks, it prevents the inhalation of toxic or poisonous gases. So this is an example of a gas mask here. Prevents toxic or poisonous gases from being inhaled. And goggles, it asks state how it protects us is by protecting the eyes from injury and harmful substances. So we don't want any chemicals to enter our eyes. And we also don't want to enter it with through our nose as well. And we also don't want the chemicals to enter our body through the skin. So whenever we need to touch something, we also wear gloves. So these are some of the materials, the safety materials used in the laboratory. Let's look at this theory question, which asks you to state what is a physical quantity. Well, physical quantity is a property of a material or system that can be measured and expressed with a numerical value and a unit. So everything that can be measured is a physical quantity and also has a unit. So if it asks you to state two physical quantities, I've listed some examples. So mass is a physical quantity. So are volume, density, length, temperature, velocity, current. All of these are examples of physical quantities, things that can be measured and has a numerical value. It can be presented as a number with a unit. So we can say a length is 5 meters or 1 meter or maybe 100 meters. It can be represented by numbers, it has a numerical value. Same with mass, you can have 50 kilograms of something, maybe 2 kilograms, maybe even 1,000 kilograms. And the point here is that they all can be represented by number and a unit, can be measured. That is quantity. So this last question and this last topic asks us to find the SI unit that is derived. So we did not learn this yet, but the International System of Units, the SI units, consists of base units and derived units are used for scientific measurements. Derived units are often maybe a combination of base units, and it might be um, maybe dividing by certain units, maybe something per something. Um, but the answer of a derived unit here is C, Pascal, and all of these rest are base units. So we will see on the next slide here. These are all the basic SI units. So meter is measured as um, a length is the basic unit for length is a meter. You can just write M for the symbol. And the basic unit for temperature is Kelvin, written in K. The basic unit of electric current is ampere, and A. For time, it is second. For luminous intensity, is candela, CD. For mass, it is kilogram for the basic unit. And for the amount of substance is mole. These are all the basic SI units. And from these units, we can have derived units. Um, Derived units are combinations of units to make scientific calculations. We have volume, which are cubic meters. So we multiplied meters 3 times. Um, Maybe when measuring the volume of a cube, you have to multiply the sides and it results in the unit of cubic meter. We learned about density, which is also a derived SI unit, because we're dividing kilograms by cubic meter. And it's not just a simple unit. Density cannot really have a single symbol. It's a combination of symbols. Kilograms per meter squared, meter cubed. For speed, it's also measured in meter per second, so it's derived. Newton, which is meter per second squared, and it can also just be written N. But the components are meter per second squared, so do not be confused. Even if the symbol says N, this is not a basic unit. It's actually kilograms meter per second squared. For joules, for energy, it is measured in joules as well. And also do not be confused because joules are kilograms meters squared per second squared. Same with pressure. Pascal is kilograms per meter times second squared. The main takeaway from this is that um, some units are derived and some units are basic. And if we return to the question over here, it asks us to state their derived SI unit. Kilogram is basic, we know that, for measuring mass. Kelvin, we know, is also basic unit, measured for temperatures. Second, we also know is basic, measured for time. But Pascal is a derived unit. See here, Pascal for pressure is kilograms per meter times s second squared. So that was actually it for chemistry. Um, do you guys have any questions regarding chemistry before we move on to um, physics, the new topic of science? Any questions so far?
Oh, yeah, last time.
Yeah, no questions? Then we can move on to the next part of science. You guys will be learning about physics, starting from today. So these are some physics questions from 2020, 2024, and these are the contents. So we will learn about energy, what is energy, and the type of energy. We will also learn about energy transfer, heat transfer, which include conduction, convection, and radiation. We will learn about Newton's three laws, We will learn about work, force, and power. We will learn about electric circuits, which involve voltage, current, resistance. Learn about Ohm's law. We'll learn about liquid pressure and movement, learn about images, light reflections, mechanics, and solar systems. So let's get started on energy. So, which of the following source of energy is non-renewable? This is asking for non-renewable energy. And always remember that energy is the ability to do work. And here we have a couple options here. We have coal, we have solar energy, we have wind energy, and we have uranium. So which of these are non-renewable? Um, the answer is actually C because let's carefully look at it before we have our answers. Um, because if you think about one, coal is non-renewable energy. Um, Coal cannot be used again once it is used up and released as um carbon dioxide into the air. Coal is not usable anymore. Uranium is also not usable, but it is often used, um, preferred by many industries because it is a very strong source of nuclear energy. But solar and wind energy um, can be um, can be sort of recycled after energy is used because we will actually see on the next slide. Here, I will talk um, more about the renewable energy here. So it actually comes from natural sources, the solar and wind energies. They never run out and can be used again and again. It can be recycled. And they are good for the environment since it has no sort of pollution. It does not cause any significant consequences after using renewable energies because they come from natural sources. Things like solar energy comes from the sun. We always have access to the sun, and solar energy from the sun can be reused. Also, wind energy, which is generated by wind turbines. We always have winds that we can collect, not really collect, but use rather, to make energy, to make the wind turbines spin. We have hydropower as well, which uses the movement of water to produce electricity. We also have biomass or biogas. It's derived from the organic materials like wood, crops, and waste. All of these are sort of natural sources. Um, they directly come from the environment, and we do not use any excess materials or anything else that comes outside the natural resources. All of these are um, coming naturally, and they do not involve any human creations. So again, here are some examples. Um, Solar from the sun, hydro from the water flow, wind from the wind flow by using a wind turbine, tidal, which actually uses the tides, the waves that is actually dependent on the moon. Geothermal uses the energy from the ground, the heat that is conserved in the ground, and biomass we also uses crops, waste materials for recycle. All of these are renewable energy. But non-renewable energy, just the opposite, comes from finite resources. These are not infinite. And all of these resources take millions of years to form, and they can run out. That is the main problem, and they can also cause pollution. The reason why many people are using non-renewable energy is because it is really high in energy compared to renewable energy. Renewable energy takes a while for energy to collect, and it maybe also depends on the day. It is not always reliable. Renewable energy is a really quick way to get a lot of energy. But again, they run out. So they are from finite resources, usually from human creations, and are non-renewable energies. Examples of coal, um, which are fossil fuel used for electricity generation. Another example is oil, refined into gasoline and other fuels. Natural gas, which is used for heating and electricity. Also, nuclear energy, produced from uranium for nuclear fission. And thermal energy, if it is from fossil fuels. Thermal energy, if it's from geothermal, like we see here, is actually a renewable energy. But thermal energy from fossil fuel is non-renewable and is also not eco-friendly because it causes pollution in the air. Um, to make things clear, let's try solving more example problems. And this might make sense for most of you. So, which of the following pairs of energy resources is environmentally friendly? So here, environmentally friendly usually refers to renewable energy. Do you guys know the answers? A, coal with thermal energy. B, wind and biogas. C, wind and coal. Or D, biogas and thermal energy. Yes, that's right. The answer is B, wind and biogas, because coal, if not, is non-renewable. So we can eliminate A and C. For D, it depends on what thermal energy it is, so it might not always be environmentally friendly. But B, we know wind. We can use wind turbines, which are renewable energies. We can also use biogas, which is also renewable energy. Yeah, great job. And let's look at this next question. Which of the following electrical appliances can convert electrical energy to heat energy? We're now talking about energy transfer, energy transformation, and how energy can be transformed into multiple forms. So, which of these can convert electrical energy to heat energy? Is it an electric iron? Is it a kettle or a water heater? And I've put the answer here actually. The answer is A, all of these. So, um, for example, if we have a kettle or a water heater, we know that we convert electrical energy since we plug the cord in the outlet, and that is the source of electrical energy, and it is converted to heat up water. Same with electric iron. We use it to plug it into the outlet, which is the source of electrical energy, to convert it to heat to use for straightening clothes. Let's look at energy transformation in a little more detail. So, changing energy from one form to another is called the energy transformation. But it is really important to note that energy cannot be created or destroyed. It just changes forms. This is actually a really important law called the law of conservation of energy. So the test might ask you to state the law of conservation of energy, but now you know that it's when the energy cannot be created or destroyed, only changing forms. So here we have transformation of electrical energy from the outlet to sound and light. If we plug in into the TV, if we have light energy from the sun, it can be converted into chemical energies in the plant by going through photosynthesis. Chemical energy from the batteries can be converted into light if it is used in the flashlight. Chemical energy is actually applying to humans too. So if we eat food, which is a form of chemical energies, and our body breaks it down, we can use it as a form of mechanical energy. We use the energy from the chemicals in the food to work, to move. We also have electrical energy in the outlet to heat. If we use a toaster to plug it in, we can also have chemical energy to mechanical energy for cars, for oil, for gasoline to movement of the car. And you can see maybe these longer chains of transformation. So sun radiant energy might be transferred into the solar panel to create electrical energy. These electrical energies can provide it to create a chemical energy, for example, a battery. And this chemical energy can be transformed into light energy if we use it to power a light source that uses a battery. So you can note that energy can be transformed into many different forms. Does anyone have questions so far regarding maybe energy transfer or energy in general? Um, yeah, if you don't have any questions, let's continue on because these are maybe a little simple concepts. So the energy transformation that occurs when sodium hydroxide is dissolved in water is it A, heat to potential energy? Is it B, chemical to light energy? Is it C, chemical to heat energy? Or D, heat to kinetic energy? So if you're wondering, um, what occurs when sodium hydroxide is dissolved in water, I've provided a little information here. So when sodium hydroxide dissolves in water, it actually undergoes chemical reaction. So from this information, we know that sodium hydroxide has chemical energy. But what is that chemical energy converted into? Well, when sodium hydroxide is dissolved in water, it also releases heat. It's a form of exothermic reaction, meaning simply releases heat. Yes, I think I heard someone say answer is C, and that is correct because you have sodium hydroxide which has the chemical energy and it releases heat. So the answer is C, chemical to heat energy. Let's look at the next question here. The energy transformation that takes place in a solar cell is, anyone know the answer to this question? So the energy from the sun we get is light, and the solar cell helps turn it into electricity. So therefore, we're converting light to electrical. Now,
Hello, yeah, we can hear you. The network was breaking. There was a break in the network.
yeah, it's okay. I
Yes,
think,
we can hear you.
yeah, I
Can
think
you
we,
hear us?
yes, I can hear you as well.
All right. Then we can proceed.
Okay,
We can proceed.
so the answer to this question was B, because solar energy is a form of light energy, and it goes into the solar cells, which convert to heat to electrical energy. So it is B, light to electric. This next question asks, in which of the following devices is electrical energy transformed into light energy? Is it A, electric bulb? Is it fluorescent tube? Is it C, lantern? Or is it D, a radio? I think I heard you say B, and that is correct. So, yes, that is right. The answer is B. And it is because you see in the fluorescent tube, the electrical energy, because we have electrical energy because we have connected to the outlet. So it converts from electrical energy into light energy because it provides light in our homes. All of these other options are other transformations, not from electrical to light. For electric bell, it is from electrical to sound. For lantern, it is chemical to light. It's not really an electrical energy because lanterns often use chemical energies of batteries. Radio converts electrical energy to sound energy. So B is the correct answer. Let's look at a theory. It asks us to state two effects of heat on a substance. So, some effects of heat, we have expansion. One example is expansion. So most substances expand when it is heated. It can also result in change of state. So heat can cause a substance to change its state, such as solid to liquid. We apply heat to solid, turns into liquid, melts, or it can turn from liquid to gas. If we heat up gas, it can be evaporated into a gas. So these are maybe other effects of heat that are applied to our daily lives. So snow melts, water boils, gradually disappears. A rise in temperature of the body. There is the expansion of objects. There's the change of states. A speeding up of chemical reactions, killing organisms. For example, bacteria present in milk and water. All of these are effects of heat. Let's look at this question, which is still on energy transfer. So, which of the following statements are reasons for conserving energy? So is it one, insufficient production of energy? Is it two, increasing demand of energy? Or three, limiting production of carbon 4 oxide? IUP. So this one is a little bit weird because the online website stated that the answer is B, which is 1 and 3 only. However, I actually think the answer is D, which is all of the above. And we will look at the reason why over here. Because the reasons for conserving energy are because of limited energy resources. Example, fossil fuels are non-renewable and will eventually run out. That will cause us to conserve energy. Increasing demand can also be a reason for conserving energy. As industries grow and populations rise, energy consumption increases and lead to shortages. So it can actually lead to increased demand for energy. It can reduce carbon emissions, like carbon dioxide, and it also can lower energy. It can also use to protect the environment because if less energy is used, conserve energy, we have less carbon dioxide um, into the atmosphere, released into the atmosphere, and it protects the environment from maybe removing the chance of pollution, deforestation, or habitat destruction. So all of these are reasons for conserving energy, for saving energy. So that is why the answer is D, because all of these can be the reasons for conserving energy, for saving energies. Now we are moving on to the topic of heat transfer. So a bowl of water on a gas stove was initially cold. It became warm after some time. What was the mode of heat transfer in the water? We haven't really learned this together, but the answer here is A. It's convection. So let's learn about let's learn about the different heat transfer. So what does all of this mean? So we have three main types of heat transfer methods. One type is conduction, which is a direct contact heat transfer. It's through it's often between materials, mainly solid to solid. An example might be a spoon getting hot in a pot of water, Or it can also be our skin contact with a hot pan, which is a direct heat transfer from that object heated to our skin. And the other heat transfer method can involve convection, which is heat moving in air or water. So heat transfer occurs through the movement of liquids or gases. It's through a different medium. And it only applies to air, like a gas and a liquid, because it is not fixed. We will talk about that too. Examples are room heating, when warm air from a heater rises, while cool air sinks, and it creates the air circulation. We've also talked about boiling water, which is an example in the previous question, which circulates in the pot. And that is how heat is moved in the medium of air or water. Again, this only applies to liquid or gases because particles can easily move in between those mediums while solid is fixed. Another method which can be transferred is by radiation, usually by electromagnetic waves. It's heat transfer basically without touching. For example, it's by infrared radiation. So heat moves through the space as waves, and it does not need air or objects, any air or objects in between to um, transfer that heat. For example, we can feel the warmth from the sun, and this is actually by the electromagnetic waves. It's by radiation. Or a fireplace without touching it, or heat from the light bulb. All of these do not involve any moving through the medium or a direct contact. It's without touching and without any sorts of air or water in between. I have a better picture here. So these are pictures comparing conduction, convection, and radiation. So conduction here, this person is touching a hot pot. So energy is transferred by direct contact from the pot's handle to the hand. Convection is where energy is transferred by the motion of molecules. So in liquid here, you can see warm water rising and cool water falling back down. Same type of process applies. Air. Warm air rises, and as it cools, it sinks back down. It's a sort of cycle. And this cycle, through the medium of water and air, is called convection. Radiation is by electromagnetic radiation. So you can see in this picture, the hand is being heated by this fireplace without directly touching it, or without the use of any convection, without the use of water and air molecules. It's transferred by these waves called electromagnetic radiation. See the difference between all these heat transfer methods. Using this, let's solve some questions. So this theory question asks us to explain the term convection as applied to heat transfer. Convection is the transfer of heat through the movement of fluids, liquids, or gases. When a fluid is heated, the warmer, less temperature rises. Warmer air or warmer liquid rises. When it is cooled at the surface, it sinks back down because cooler is a denser part of it. And this cycle forms a convection current. Always remember, convection flows in a current. Warm going up, cool going down. The second question asks us to give two reasons why convection does not occur in solids. I've talked about briefly, but in solids, particles are closely packed and can only vibrate in place. But convection involves molecules moving throughout. It forms a cycle. And they cannot, since solid cannot move easily, like liquids or gases, they are not able to flow. The particles are not able to move and generate heat that way. So the heat transfer is limited. It's usually only by conduction, which is by direct contact. So here we have particle arrangements of solids, liquids, and gases. We can see that there are spaces for gases, a lot of spaces in between. For liquids, we also have some spaces in between, so the particles are able to move around freely. Solids, however, the particles are really closely packed. So these particles cannot move around easily and form a convection cycle. Not able to do that for solids because the particles cannot move out of place easily. Let's look at this question. We are probably going to finish up today's lesson by heat transfer, and next time we will get to other topics, but let's try solving this question. So the heat from the sun is transferred by, is it conduction, convection, or radiation? Does anyone know the answer? Yes, that is right. The answer is C, because I think over here it says the heat from the sun is transferred by radiation. We know that the space is empty, but heat is still reaching Earth to us humans. And we can feel the heat from the sun without directly touching it. So that is why radiation is the method for heat transfer from the sun. Answer is C. The mode of heat transfer in which no material is involved is known as
No material.
Does anyone know the answer to this question?
No move.
Yes, that's right. I think I heard it, and that is correct. Radiation does not involve any materials in between. We just had an example of a sun radiating energy through the space. So space is empty. There's no material in space. But radiation is still able to reach Earth. Other bits, like we see here, conduction and convection, they both involves direct touching, or any materials in between. Convection involving water or air, but radiation. Yeah. I think this is the last question for today,
Say,
and it asks a metallic ladle was left in a boiling soup. This is a ladle, and it is left in the boiling soup. After some time, the handle became hot. This is because the particle in the ladle is it A, undergo rapid random motion? Is it B, contain free electrons transfer energy? Yes, that is right. The answer is B because we can see here that we did not really talk about this, but now we can see that metals are good conductors because they have free electrons that move easily. When one part of metal, for example, the end of this boiling soup gets hot, these free electrons transfer heat to the cooler parts, for example, to the handles. And this is a process of conduction, and it is really important. The reason why. Because the hot soup is in direct contact with the metallic ladle, and the heat from the fire is transferred into the soup by conduction, and from the soup to this cradle, just ladle. And eventually, the free electrons transfer the head of the ladle all the way to the cooler parts, handle as well. All of these processes, you can tell, is by conduction. So that is the main takeaway here for today. The three methods for heat transfer, and we also learned about energy, the transformation of energy. And for chemistry, we also learned about renewable energy and non-renewable energy. And we also learned for chemistry about osmosis and diffusion. So, before we end, have any questions? Nobody have a question? Then this is the end for today's lesson. So, I so the slide has been already shared. I will share the slide to you shortly. And you guys can take a look at some of the problems that we solved today. And next time, we will learn more about physics, especially about Newton's law, forces, and other formulas such as mass acceleration. We'll learn about other gravitational forces and others as well. So I will see all of you next week.
Okay, David. Thank you for your time.
Yeah,
Are you hearing me?
yes, thank you.
So next week we'll be vacating. I don't know if Prince
Yes.
has told you that already. Are you aware?
Sorry, can you repeat that, please?
Hello, JB.
Yes.
Yes, I was saying that next week we will be vacating. School closes next week.
Oh,
I will go
okay.
on vacation next week.
Oh, I see.
Yeah, so
And,
I want to find out if Prince has already told you.
okay, so we will meet in
I want to find
two
out
weeks
if
from today, from 2 weeks from today, right?
yes, so I'm sure today will be the last week. Yes, 2 weeks from today. Yeah,
Okay.
yeah, yeah. Yes.
Yeah, that sounds good. And um,
So next week,
while
I'm not sure we'll meet.
okay, yeah, that is fine, and we can meet 2 weeks from today. Yeah,
Yeah, sure, sure.
yeah, I will see all of you then.
Okay.
Yeah, yeah. Thank you everyone for listening today's lesson, and yeah, bye everyone. Bye.
I see you.